The video that you're about to watch is on reproductive and development, but I think I want to remind you that it's mostly going to be meiosis and embryology. This is going to be a very vanilla video, and so if this is being played in an office somewhere or if it's being played in a soccer mom van, you are safe, and I don't think you'll have to answer too many questions after this video. Let's talk about meiosis first. And meiosis is gamete formation, and when we talk about gamete formation, we're talking about sperms and eggs. The original is called a spermatogonium, and it has, in the male, and it has the full count, 46 chromosomes. It is called 2N or diploid. And what happens is spermatogenesis occurs in the seminiferous tubules. But before we get to that, let's talk about some of the hormones that influence all of this. Gonadotropic releasing hormone is released from the hypothalamus. It affects the release of follicle stimulating hormone from the anterior pituitary. This stimulates what is called androgen binding protein, or ABP, which then stimulates testosterone, which then stimulates spermatogenesis. Here's what I want to say. For all these years, I have told and taught that FSH is what stimulates spermatogenesis, and it does. But as you can see through this cascade of events, testosterone is the hormone that's eventually attributed as the one that stimulates spermatogenesis. In the male, there are 4 swimmers. There are 4 that are produced from an original spermatogonium. They are all 23N or haploid. And the way that I remember haploid is, to me, it sounds like half. Why is that going to be important? Because a 23 sperm fertilizes a 23 egg to make 46, which is human. There is such a cute event that happens, I can't not talk about it, but I believe it's meiosis 1. There's a process of synapsis and crossing over where homologous chromosome pairs get together, and as you can see in this picture, there's a red chromosome and a blue one, and now there's a red tip on the blue one and a blue tip on the red one. Why is this important and why is it cute? Because it makes every one of the sperm or every one of the eggs slightly different from the last one. It's why you look kind of like your sister or your brother, but not all the way like your sister or your brother. And basically it just puts diversity within the family. And here's what I'm not sure if I'm right in saying this, but I just want to speculate. Some of the families where you see every child is a cookie cutter version of the last one, where they all look like they're twins, even though they're stair-step, I think that maybe there's not as much of this crossing over happening in the gametes that are making these children possibly, and that may be why they look all so very similar. I'm making that up. Well, there is a difference between spermatogenesis and spermiogenesis. Spermiogenesis is the maturation of the sperm. These apparently are matured in the epididymis. Let's go back to the top of the board for just a moment. There are some cells called sustentacular cells, Nurse cells, Sertoli cells that aid in maturing spermatids, and they secrete androgen binding protein, ABP, and also inhibin. Remember that it's inhibin that helps to stop some of this production or slow down some of the production in the male. And I think I'm going to leave it as that. Remember that when the sperm are swimming toward their target in the host, there is alkaline pH of the fluid, and that creates something called capacitation, and it makes it easier for the sperm to get into the egg and make a baby. One of the things that I will say while I'm here, and I may be kind of getting ahead of myself, but there is such a thing as menopause. Us guys like to think that we're rather smooth, but we have our little hills and valleys. Menopause and menopause are when the man and the woman kind of begin powering down some of the reproductive features of their body. I'm not really sure if I said that the way I wanted to say that, but that will have to be how it rolls for the moment. Remember that if there's abstinence, this is a major prevention for pregnancy. Let's talk about the ladies for just a moment. The female egg begins as an oogonium. It also has 46 chromosomes, 2N, diploid, and this basically is development of the ovum, which is this big cell, and polar bodies. Now, here is where a problem lies, and we're going to go to the right side of the board in just a minute. But I had always taught that there's one oocyte and 3 polar bodies that the lady has. But we're going to see in just a minute that when we count it all up, it looks like one oocyte and a couple of polar bodies, and even the second polar body, I'm not even sure that it even split the chromosomal material. Just know that polar bodies in the ladies disintegrate, they're not fertilizable. So in the ladies, even though you might start with one oogonium, you get one fertilizable entity. And so let's go over to this side of the board for just a minute. Remember that ovaries are the main female gonads. And so I think that this meiosis in the female is very intriguing. And so I hope that I can articulate this the way I want to do that. Remember that before birth, the little girl has 2 to 4 million eggs in her body. And these are all 2N. And meiosis begins and produces what is called a primary oocyte, which is still a 2N entity. And then this kind of remains, I don't want to say dormant, but nothing really happens until the reproductive years are reached after this process happens. And at the time that we have a secondary oocyte formed with the release of a polar body, we go from 2N down to N. So in this first polar body, it appears that half of the chromosome material has been cut away. And so now we're down to a 23 chromosome oocyte, a secondary oocyte. She has about 80,000 to 400,000 of these. Some sources say that in her lifetime she'll ovulate 400 to 500 of these eggs. But think about this. If a lady's fertile for 30-ish years and there's 12 months in a year, 30 times 12, that's 360. So this 500 might be a little bit high for how many eggs a female might release in her lifetime. Maybe, maybe not. Kind of depends on the person, I think. It's very interesting that her egg doesn't completely undergo all of its divisions until fertilization occurs. This is kind of strange to me. But when the sperm interacts with the egg, 23 and 23 make 46 of a baby, which is you, by the way. Amazing. There is another split and a second polar body is formed at this time. And then this 2N entity is called a zygote or a baby, however you would like to call that. There are some terms for the development of the baby. In the first couple of weeks, the baby is called a zygote. 3 to 8 weeks, an embryo. 9 to 38 is a fetus. So these are kind of the science names for the baby. But let's talk about the development of the baby, and I might go back and add in a couple of cute little things here before we end. When the baby is formed, and remember this zygote probably formed somewhere out in the fallopian tube. It's going to take a few days for this baby possibly to embed into the endometrial lining. It goes through a 2-cell stage, a 4 and 8-cell stage, and then it forms a little berry of cells called a morula. But let's go back to the 2-cell stage for just a minute, because that's where some of the cuteness happens. If in this 2-cell stage, if the cells split completely and form 2 different entities, then what kind of twin do you have? Same egg, identical twins. This is a monozygotic twin situation. Monozygote means one egg. But if a separate egg is fertilized, 2 separate eggs are fertilized by 2 separate sperms, then what do you get?
Dizygotic.
You get dizygotic or fraternal twins, and so that's how you can have you could have a male and a female who are twins and in the womb at the same time. My understanding at this 8-cell stage, this is when researchers can remove a cell from this 8-cell unit and begin a stem cell line, and that has a whole other discussion that can go along with that. But I'm just going to mention that. Remember that we go to what's called a morula stage, then a blastocyst stage, probably around the time of embedding is blastocyst. This, some people say this is an immature embryo. It then goes to a gastrula phase, which is called a mature embryo, at which time a primitive streak forms in the little baby. Why is this important? Because this is when the head and the tail are established, right and left are established, and then resulting we have endoderm, ectoderm, and mesoderm. Remember, endoderm is what forms your gut. Ectoderm, skin, hair, nails, and then as this invaginates, it makes the spinal cord and the brain, and then mesoderm is what forms muscles and bones. Around the baby itself, as the baby continues to mature, there is a yolk sac, an amnion, allantois, and a chorion. The yolk sac is what forms most of our part of our digestive tract. The amnion gives protection to the baby. Allantois is part of the umbilicus. It forms part of the bladder, and the chorion is what forms the placenta. So I want to talk about a couple of cute things here before we end. One of the cute things is that HCG, human chorionic gonadotropin, is what's released from this outer layer, this trophoblast, this placenta, and that is what is picked up on a stick that a lady can participate and find out if the baby, if she's pregnant or not. That's kind of a cute thing. Another thing is this. Remember how I told you there are 4 swimmers made from a single spermatogonium? Well, at the time all of these swimmers are competing, they're competing against about 400 million of these. And so the amazing thing is that you were the one that won the prize and got to wear the party hat that day. You were the fastest and the best. You're truly not just 1 out of a million, you're like 1 out of 400 million. And I've even heard it said that for every fertilized egg, only about half of those make it to full term. So really, honestly, you're probably 1 out of 800 million or 1 out of a billion. You're that amazing. That's what I'm trying to tell you, and remember that. Holla out loud, answer the roll. Say it like you mean it, not just present, but president. Not just present, but president. Not just present, but president. I just want you to get bossy with your education. Be the disciple. Keep coming back. Remember, A is for excellent, B is for better, and C is for super.